How can you do that? So first of all, suppose if you don't find any, if you are not getting any reagent, right? So the best way to think of the reagent is to compare the formulas, and they can help you out to decide which reagent to be taken. So tell me any idea which reagent can be taken.
Say H2SO4.
Yeah, it is addition of water. Okay, so the preparation of from alkynes, preparation of aldehyde and ketone from alkynes is actually, it is acid catalyzed hydration of alkynes, right? So you take alkynes and you add water to it. Okay. Yeah, Memuna, good evening. You add water to it, and water, but water doesn't add directly because water is doesn't have sufficient amount of H plus in it. It is neutral. So you take H2SO4, that's true, and apart from that you take HgSO4 also. Okay, HgSO4, H2SO4, and sometimes it is written as Hg2 plus, right? It will be written as Hg2 plus. You will find it in many books. So they will simply write Hg2 plus aqueous. So that is both the H2SO4, HgSO4. Okay, HgSO4 acts as a catalyst. Okay, it actually forms a complex with triple bond, and thus it helps in the addition of water. Is it clear? This is Markovnikov addition of water. And Markovnikov means H2 you are going to put here and O you are going to put here. Is it clear?
Yes, sir.
Markovnikov addition of water, right? And how can you do the anti-Markovnikov addition? This is Markovnikov addition.
So under peroxide.
Yeah, but what else do you need along with the peroxide? Memuna, you can try this. What else do you need? You need peroxide. So suppose if you wanted to add HBr, you took HBr along with peroxide. That actually led to the anti-Markovnikov addition of HBr. But how you are going to add water in anti-Markovnikov fashion? Is it clear? So that you can tell me quickly how you are going to add water. Any idea? Actually, you need to remember it because we did the addition of water in anti-Markovnikov fashion on alkenes also. That's why I'm asking. So just try to recall that and just apply the same thing here also. Yeah.
So HBr.
No, HBr will add H and Br. I want to add water only. HBr is okay. HBr along with peroxide, that is correct, but that will add water. Why will it add? Why will it add oxygen? Okay, we want oxygen to be added. Yeah. So it is. So you don't add water directly. Remember, we did this for alcohols also. Okay. So what we do, we we do hydroboration that adds hydrogen and boron. Is it clear?
BH3, right, sir?
Yeah, BH3. BH3 actually it is written as BH3 or B2H6. Okay. Actually, BH3 it is mixed with THF, which is an ether. Along with along with the oxidation. Okay. Oxidation, now you are going to take NaOH, NH2O2. So could you recall this?
Yes, sir.
The same thing we applied on alkenes. But there we ended up with alcohol.
Yes.
And if you do it on the alkynes, you ended up with aldehyde and ketones. Okay, this is but this facilities you are going to avail only for the terminal alkynes. I hope that is clear. Is it going to give a different product if you do the Markovnikov and anti-Markovnikov addition of water?
Yes, sir.
How? Two different products. When you are doing direct acid catalyzed hydration in the presence of dilute H2SO4 and HgSO4, you are going to get something and you are going to get something else if you are going to use hydroboration and oxidation. Are we going to get two different products? So look at the nature of the alkyne. Then we can decide that. Yeah.
So we can get oxygen group on any of the two carbons in the middle, like which
Actually,
has
both carbon are same.
yes, sir.
Okay, and because both carbon are same, Markovnikov and anti-Markovnikov, whether you are going to add H2 here and O here or O here, H2 here, it's not going to affect the mode of addition. Clear?
Yes, sir.
Both are going to give you the same product. Memona, is it clear?
Yes.
They are going to give you the same product. Here also we are going to get this. So only it works only for your terminal alkynes, means which are at the end. And terminal alkynes you can differentiate, right, between the Markovnikov and anti-Markovnikov addition, right?
Yes, sir.
So they will not write H2, sometimes they will write H2SO4 dilute or simply write Hg2 plus dilute. So just if it is written Hg2 plus, always remember that it is the alkyne which is given. Okay. So what are we going to get? What is the common name of the product? And what about this one? Yeah, tell me quickly. What's going to be the answer for both of them? The first one is Marconi competition. Okay, because you have taken dilute ester suppose, so H, which is going to get added to the position where already one H is there. And the second one is anti-Markovnikov because you have used hydroboration oxidation. So that is going to be the reverse. Okay, clear? So
Yes, sir.
if that is reverse, so in the first case you are going to get acetophenol. PHC double bond O is going to come inside and H2 is going to get added outside. Right? In the second one, this is anti-Markovnikov addition. So this is just the reverse. Hydrogen will add inside where there are less hydrogens. Okay, and you are going to add oxygen on the outer carbon, CH2, CH. Okay.
So what will be the IUPAC name for the first one?
First one is the principal chain, parent chain is this one. Okay. So that is 1-phenylethanol.
Okay, sir.
Okay. And for the second one, it is 2-phenylethanol. Right?
Yes, sir.
Okay. So I hope this is clear. So addition from alkynes. Now the next is, this is alkenes you can't add directly. Alkenes you can add water and you can oxidize the alcohol. Okay. Now the next method is from alkyl halides. If you have PHCH2Br, how you are going to convert it into PHCHO? Yeah. How you are going to convert this Br to double bond? Okay. Or if you have CH3CH2Br, CH3CH3, same. How you are going to convert it into CH3CHO? Yeah.
Sir, NaOH?
Anyway, directly for which one? For the upper one or for the lower one?
The upper one.
Upper one is you can do, yeah. First step is you can use aqueous KOH. Okay. That will bring in the OH. Okay. Once you have the OH, now you just have to bring in the double bond. Yeah, that's true. And so how you will bring in the double bond, that we have seen in alcohol chapter. Yeah.
So H2SO.
Bring in, no, that is oxidation. Okay, double bond. So first step, I can write them separately. Okay. So first I can write it like this, pH, so that you don't get confused. PHCH2Br. Okay. Br it will convert to OH by substitution, PHCH2OH. Right? And then you can remove both the hydrogen, and that is oxidation. Okay, H2SO4 will do brings in double bond by removal of water. But you don't remove water. Don't remove water. You need oxygen because you wanted double bond. You wanted benzaldehyde. So mild oxidizing agent. Which was a mild oxidizing agent? Memuna.
PCC.
Yeah, PCC you can use. Krishna, Memuna. Clear? Understood? And suppose if you have to start with alkanes, then what you are going to do? You can adopt the same method, but one extra step is required. Yeah. Which extra step is required?
So we can react it with SOCl2.
So no, wherever first you can bring in the Br. Okay. So how will you bring in the Br?
So HBr.
HBr, no, that is on alkene. On alkane, the best way to bring in the Br is by photohalogenation. Okay. Is it clear or not?
Yes, sir.
Vemuna, could you recall photohalogenation of alkanes? Right. So Br, if you have, just you can use KOH, aqueous KOH, and that will change it to CH3, CH2Br, OH, and then you can take the PCC, which will oxidize this OH2 double bond. Okay, that could be the one of the method, right? So this is so there is a very famous question asked in many examination. So suppose if you have toluene, you know, methyl benzene, okay, and you did chlorination, right?
Yes, sir.
And then you did reacted it with KOH aqueous. Okay. So which of the following product cannot form in the reaction? You have to answer the one which cannot form in the reaction. Got it? Which is not at all possible. Yeah. You did chlorination, you reacted with the KOH aqueous, So which is not possible. Okay, that you have to tell me, right?
Yes, sir.
I will give you a hint. It is not told to us that how many times you did the chlorination. And the chlorination which you did is actually the photohalogenation. Photohalogenation, which there are two types of chlorination actually which can occur in this place. So one is a chlorination of benzene, another is a chlorination of the alkyl side chain. You need to concentrate on that. Yeah, Vamsi.
So is it option 2?
Option two, Memuna would like to add something. It's option 4. That is not possible. Okay. So first of all, yeah, this is a difficult question. Okay. So first of all, actually you need to know that this is the photohalogenation of alkane, not of the benzene ring. Because for benzene ring, how you do the carry out the halogenation? For benzene, how you carry out the halogenation? Yeah. For benzene, you take Cl2 in the presence of Lewis acid,
Lewis acid, yes, sir.
right? And this is the photohalogenation, which is for alkanes. And this is the alkyl side chain. But in this question, you don't know how many times the chlorination has occurred. And they have not given you any information. The question has not given any information. So it could be this, and it may happen 2 times also. It could be this. It could be this also. Okay. Do you agree with this?
Yes, sir.
But it could not be this one. Right, Memuna? This cannot form. Because this would have formed if you would have taken Cl2 and FeCl3. So this will not form under any condition. Okay, now, now you do the hydrolysis. You can see it. So if you have one Cl, the hydrolysis is very simple. pH, CH2, OH. If you have two chlorine atom, you will have two OH group. Think in this way. And remember, we did this hydrolysis of dichloride in that Riemann reaction also. Remember?
Yes, sir.
So actually, this is unstable, so it removes water. It forms benzaldehyde. Okay.
So the second option is the correct one.
No, benzaldehyde can also form. This can also form. So first option is also. So I'm asking you which of the following product cannot form in the above
Okay.
reaction. So this can also form. And suppose if you have pH C Cl3, that could have formed. That could have also formed. Okay. So if this would have formed PCH CCl3, its hydrolysis would have given what? Tell me.
CCl2OH.
Actually, CCl2OH and the other Cl will also get displaced, and PHC, and you will have 3 OH groups. Think in this way. Okay, which will be unstable, so water will be removed. And so one more thing, very important thing which we learned from this question. If you have 1 OH, that's it. If you have 2 OH on the same carbon, water will get removed and you will end up with aldehyde. Okay. And if you have 3 OH groups, the water will get removed, you will end up with carboxylic acid. Okay. Is it clear? So which is never possible? That's what I have asked in this question. Which is not at all possible? The answer is your option D. Okay. 4th one, which is actually, what is the common name for the 4th one? That is resorcinol. Okay. Benzyl alcohol, benzaldehyde, benzoic acid, and resorcinol. Okay, the resorcinol can never form in this reaction. Okay, very important question actually. All of my students, to whomsoever I have asked, they are actually do this wrong. Okay, so be careful, right? And what about this one? So this you understood. So actually you can also directly, so either you can bring in the 1 halogen and you can replace it by OH, and then you oxidize the alcohol. You will end up with your aldehyde. Okay. Or what you can do is you can bring in 2 OH groups. If you are bringing in 2 OH groups, automatic or at the same position, that is also very important. Okay, if you are bringing in this 2 OH group at the same position, what you are going to get? The water is going to get removed and you are going to get double bond. Clear? Okay.
Yes, sir.
So this is Memuna, is it clear? Very important question. So this is,
Yes.
yeah. Okay, so this is the preparation, and very difficult. All of the people do it wrong first time. So don't worry about it. But try to learn the concept behind it. Next is method of preparation. We prepared from alkynes, we prepared from alkyl halides. From alcohols, we have already seen. That we know by mild oxidation. But for mild oxidation, you need to be careful only for the primary alcohol. But secondary, you don't have to worry at all. Okay. Secondary alcohol are going to give you ketones only. Actually, if there is a double bond, you need to be very careful. If there is a double bond, there are chances that the double bond will also get oxidized along with the OH group. So you take Jones reagent. Okay, the Jones reagent is actually doesn't oxidize the double bond. It is CrO3 dissolved in dilute H2SO4. Okay. and acetone. So only this will get oxidized. Your double bond will remain intact. This is known as Jones reagent. Okay. But for alcohol, it is a strong oxidizing agent. So primary alcohol are going to change to carboxylic acids. Okay, but the double bond will remain intact. Okay, so this is what we have already discussed.
So,
Just
aqueous
yeah.
H2SO4 and acetone together are called Jones reagent.
Along in the CrO3, this is the main oxidizing agent.
Okay, sir.
Okay, this is called Jones reagent, right? Other ones are the TCC that we have, copper red hot tube that we have already discussed. Okay, so alkenes you can convert to aldehyde ketone. Alkenes, suppose if you want to oxidize, here we have protected alkenes. You can oxidize them. You can break them. That is called oxidative cleavage of alkenes. So alkenes can be converted to aldehyde and ketones by ozonolysis. Okay. So what do you understand by ozonolysis? In 11th, you must have studied.
Yes, sir. Addition of O3.
Yeah, addition of O3, but actually what happens is, what is the overall effect? So there are two types of ozonolysis. One is the oxidative ozonolysis and the reductive ozonolysis. Actually, ozonolysis means cleavage of your double bond by ozone. Okay, that is ozonolysis. Cleavage of double bond by ozone. Ozonolysis. Okay, lysis means cleavage. So there are two types of ozonolysis. It's very simple. You need to cut the double bond. Okay, but you need to look what else is given along with the ozone. Okay, is it the zinc or dimethyl sulfide given? Is it clear?
Yes.
If it is zinc and dimethyl sulfide, it is called reductive ozonolysis. So before getting into the details, I'm just telling you the main thing, but which is the most crucial for solving all the problems. Okay, if you have zinc and dimethyls, any one of them, zinc is the most common. So then it is very, very simple. Just cut the double bond and put double bond O. Okay. Right. So this is oxidative ozonolysis is the most simple, and you get questions in both the directions. You get questions in which you are given provided with alkene and you are asked what is the product which are going to form, and vice versa. You are provided with the products and you are asked what is going to form, what alkene, what is a suitable alkene which is going to give these products. Another ozonolysis is oxidative ozonolysis. If zinc is not given, or if simply water, or if H2O2 are written, these are the oxidizing agents. Or sometimes you are going to find Ag2 also. Okay. So that is oxidative ozonolysis. So in this case, you need to be very careful. So you are going to do whatever you are doing for the reductive. Clear? That you are going to do. But there is some extra thing which you are going to do. And that is, if any one of the part is an aldehyde, if any one of the part is an aldehyde, you are going to oxidize that aldehyde into carboxylic acid. So this was aldehyde, right? And why it was aldehyde? There was one hydrogen over here. Clear? Have you understood the difference? Listen very carefully. This is the main difference which you need to know, and which will help you out to solve all the answers, okay, all the questions. So you need to check whether the ozonolysis below ozone, what is written? Is it oxidative or reductive? Okay. If it is reductive, you need to cut the bond. That's it. Okay. And that will give you the answer. But if it is oxidative, then you need to be very careful. Okay, then oxidative ozonolysis, you need to cut the double bond. And if there is any aldehyde which is forming, your aldehyde, you can convert, you can oxidize it to carboxylic acid, right? Memuna, is it clear what I'm trying to say? Okay.
Yes.
So that is the most important difference between these. Okay. For example, what products are you going to get for the benzene oxidation, ozonolysis of benzene? O3 zinc. And how many moles of ozone will be required for 1 mole of benzene? Yeah, tell me. How many moles? For each double bond, you require 1 mole of ozone. Okay.
4 moles. I mean 3 moles.
3 moles. Yeah, 3 moles will be required. So actually, they may ask you how many moles, and it will be, the information will be given to you. Okay. You can look at the number of double bonds in one molecule. So 3 moles will be required, and what you are going to get? Yeah. What are you going to get? So just cut it like this. Okay. And you have hydrogens. Okay. So what you are going to get? What is the IUPAC name of the product and how many moles? Yeah, Memuna, what's the answer? IUPAC name of the product. Obtained from the ozonolysis of benzene. Yeah.
So ethanol.
No, not ethanol. Just break the double bond, put double bond O. That's it.
So formaldehyde.
No, look, try again. So here you are going to put oxygen, CH, single bond. Here you are going to put oxygen, double bond. Clear? Here you are going to put oxygen, here you are going to put oxygen. Here and here you are going to put oxygen. Okay.
Yes,
I'm
sir.
doing it in a shortcut way. Right? Wherever you are cutting the double bond, put double bond O. So what this thing is going to form? C
So
H
ethanol.
ethanol. Ethane 1,2 diol. Okay, 3 moles, right? Is it clear? Ethane 1,2
Yes, sir.
diol. Okay. And there is another question. Memuna, is it clear?
Yes, sir.
So, yeah. So very important. So other question where everybody goes wrong is xylene. Xylene is dimethylbenzene. Okay. And this is orthoxylene. Okay. Clear? So here everybody makes mistake and very famous question. So you ozoneless, you reacted this molecule with 3 moles of ozone. Okay. And what are the products which will not form during the ozonolysis of xylene, orthoxylene? Is not the product of ozonolysis. Of orthoxylene. Which is not the product of ozonolysis. Understood?
Yes. So option B and D.
Yeah, Memuna, would you like to add something? Then we can discuss. Actually, the answer is, it is single correct. Only D. And you may feel surprised at how A, B, C may have formed, right?
Sir, I got about A and C, but I'm not sure about B, sir.
Yeah, yeah, everybody miss this. Everybody. Yeah. So any two you will get. Memuna, would you like to add? You will get any two. Okay. But you will miss one. Okay. So all three will form. Okay. It's a very small concept, and let me tell you, the concept is, I have given this structure. Okay. Vamsi, Memuna, and you need to consider this structure also. Clear? What's the difference and why we need to consider this? Because of the resonance. Okay, the double bonds are going to change their position, and you need to consider both of them. Okay, so this, if you break it, you are going to get this C. This is going to form C. Okay, this is going to form A. This is going to form A, right?
Yes, sir.
But if you do the ozonolysis of this molecule, what you are going to get? This portion is going to come out as A, this portion is going to come out as A, and this portion is going to come out as what?
B.
B, right? So this is a common mistake which everybody makes. So be careful about it, right? Memuna, is it clear? So ozonolysis. So what are we going to get? Yeah, with O3Zn and O3H2O2. Yeah, tell me. Yeah. What is A? Yeah. What is A? Tell me. Yeah. What is A? Are you feeling the disturbance?
Yes, sir. There is slightly.
Is it very much?
No, sir.
If it is very much, you can tell me. I will do something about it, right? So yeah, tell me. What is A? Ozonolysis. If you do the ozonolysis, what you are going to get? Yeah. So break the double bonds. Clear?
Yes, sir.
And if you break the double bonds, uh, just try to put double bond O in place of the double bonds. Okay. Right. And what is
Yes,
this
sir.
portion going to come out? There is one carbon atom. There is one carbon atom. What this portion is going to come out as?
So all the aldehydes will become into alcohol. I mean, carboxylic acid.
Yeah. No, in this only in this A plus B, there is one more product which are going to we are going to get. What is that B?
So formaldehyde.
Yeah, that is formaldehyde. So I've cut this double bond. There is one carbon atom. Okay, and don't forget this carbon atom, because this is where everybody make mistake, right? So HH. Okay. So this is the B. Clear? And what about this? I will name it as P and Q. What are P and Q? Tell me. What are P and Q? Yeah.
So P will be the same thing as A, but will have all OH groups. All aldehydes will be replaced by carboxylic acid.
Yeah, all aldehydes will be replaced by carboxylic acid. So the main structure is going to be like this. But here, this is an aldehyde. So it is going to change to carboxylic acid, right? And
Yes, sir.
double bond O. And what about this one? So this is P, the main product. What is this? This will change to what? Yeah.
It's a methanoic acid.
This is going to change to methanoic acid. Actually, now listen very carefully. There are two hydrogens which can be oxidized. Okay. Two hydrogens can be oxidized. So if you oxidize one hydrogen, it is going to form methanoic acid, but there is hydrogen on one more side, that also you can oxidize. So what it will form ultimately? Yeah. What it will form ultimately? Yeah. Tell me. So it is going to form OH and OH. Clear? This is which molecule? Yeah. This is carbonic acid. So carbonic acid, we know it is there in the cold drink, and it get oxidized to it breaks into CO2 and H2. Clear? So what we are going to get? We are going to get this and CO2. Clear or not?
Yes, sir.
So the terminal oxidative ozone-lases, the terminal double bond, doubly bonded carbon is going to come out as CO2. Is it clear?
Yes, sir.
It is going to come out as CO2, right? So this is the ozone-lases method. In oxidative ozone-lases. In reductive ozone-lases, it is going to come out as formaldehyde. In oxidative ozone-lases, the formaldehyde is going to come out as not formaldehyde but carbon dioxide and water. Okay.
Yes.
So compound A, which upon ozone-lases gave hexane, one 6-dioic acid. So what's the structure of this? This is the reverse question. Yeah. So what are we going to get? If we have O3 and H2, O2. Even if water is written, that is going to be oxidative ozone-lases. Right?
Yes, sir.
So what we are going to get as A? So structure of A is it going to be this one? Or is it going to be this one? Is it going to be this one? or is it going to be this one? Yeah,
Option B.
option B, right? Okay, so this is going to break, and cycloalkenes are going to give you dicarboxylic acid or dialdehyde. Okay, and this is going to give you 1, 2, 3, 4 butane dioic acid. Okay, and this is going to give you propane dioic acid, and this is going to give you cyclohexane dione. Clear? Is it clear?
Yes, sir.
Right. So now we move on to another method. Of preparation of aldehydes and ketones. Okay. This is, so we prepared from alkenes by ozonolysis. We prepared from alkynes by acid catalyzed hydration, by hydroboration. We prepared from alkyl halides. Okay. Alkyl halides can be converted to alcohol, which can be oxidized. Okay. Or alkyl halides can be converted to dihalides and they can be hydrolyzed, right? So similarly, you can have this. Okay. Preparation of aldehydes and ketone by different methods. Okay. Now we move to the most important thing and most important way of preparation of aldehyde and ketone, that is from carboxylic acids and their derivatives. From carboxylic acid and their derivatives. Okay. So carboxylic acid and its derivative can be used to prepare aldehydes and ketones. So first is RCOCl from acid chloride, which is the most important carboxylic acid derivative. Yeah. So how you are going to convert it into aldehyde? That's the question. There are two different routes. One, you can use it to convert aldehyde, convert it to aldehyde. Another one is you can convert it to ketone. Yeah. So tell me how you can change it to aldehyde. Yeah, Memuna. Any idea? How can you convert it to aldehyde? So you need to bring in one H. Okay. Yeah, Vamsi. So you can convert it to aldehyde by doing partial reduction. Okay. Partial reduction of acid chloride. So partial reduction, what you are going to use?
PCC and PDC.
No, those are oxidizing agents. reduction, partial reduction means you are going to put H. Just one H you need.
So H2O.
No, that is hydrolysis. Just one H you are going to use for partial reduction. Actually,
So,
this is
so H2SO4, H plus H2.
that is actually, if you are adding a neutral molecule, that is not oxidation or reduction. Reduction means you are simply adding water. Okay, so actually the thing is, you are going to use Rosenman reduction. Okay. So Rosenman reduction is actually catalytic hydrogenation reaction. Okay. RCOCl, acid chloride. You take hydrogen. Okay, you take catalyst. Catalyst is palladium. But what happens is, if you take a catalyst, it is going to reduce completely to alcohol. Okay. But you need something to stop the catalyst from reducing it further completely. Okay. So you took catalytic poison, BSO, H2PDBSO. Okay. And that will reduce it, but not the complete reduction, just the partial reduction. RCOH. Is it clear? This is the partial reduction, and you have taken the catalyst for hydrogenation reaction, but along with the catalyst, you are taking catalytic poison. Catalytic poison are the substances which deactivate the catalyst. And why we want to deactivate? Because we don't want to completely reduce it. Okay. So this is a very important reaction. Just remember it. Another method is you can take diol H also. That is also a weak reducing agent. What is diol H? Lot of questions are being asked related to diol H these days in NEET and JEE everywhere. What is the full form of diol H? Diisobutyl aluminium hydride, right? So it is actually isobutyl is this one, aluminium isobutyl hydride, this one. So this is actually mild reducing agent, so you end up with only one H being added. Okay, but you need to be very careful. By mistake, if you would have taken LiLH4, then it will be a problem, because LiLH4 is having 4 hydrogen. It is a strong reducing agent, and it will not stop until you have reduced it completely. Okay, so what you will get if you would have taken LiLH4? Yeah, tell me.
So carboxylic acid.
No, that is oxidation. You are not adding oxygen, you are adding hydrogen. Yeah, what it will be. So first of all, you will have one HH added. You will end up, you will have aldehyde in the intermediate stage. Okay, but that will not be the sole product. The aldehyde, the reaction will not stop at aldehyde because you have multiple hydrogens. Okay, So the aldehyde is going to reduce further to alcohol. What will happen if you add H and H again? Okay, so ultimately you are going to have RCH2OH. Is it clear?
Yes, sir.
What I am trying to say, is it clear? So if you would have taken strong reducing agent like lithium aluminum hydride, the reaction will not stop at aldehyde stage only. Aldehyde will be just an intermediate and it will get reduced completely to your alcohol. Okay, right? So this is very, very important thing you need to remember. So this is the preparation of aldehydes from acid chloride by Rosenman reduction. Rosenman is partial reduction. Okay, where you take RCOCl acid chloride and H2PD along with the poison, catalytic poison. The poisons deactivate the catalyst, thus prevent the reduction to happen completely. You will have only aldehyde. Okay, and how you are going to get, suppose if someone asks you, this is very, very important, do remember Rosenman reduction is very important, that is of top priority. Okay, and how you are going to get a ketone from RCOCl? Ketone is actually let's say you want to make RCOCS3.
Sir, by Grignard's reagent?
Yeah, actually you need to think, when you are trying to connect two carbon, what's the charge on this carbon? This is partial positive because it is connected to electronegative atom. So the carbon atom which you are going to bring in to which you want to attach at this should be negative. Okay, and how the negative carbon? Yeah, you can bring it in the form of Grignard, because CH3Cl you can take, and CH3Cl you can react it, heat it with magnesium, you will end up with CH3MgCl. So Mg plus 2 CH3 minus Cl minus. Okay, so this is going to come in, right? This is going to come in, and so what is the mechanism? Little bit we need to know so that we can do the questions in a better way, and this mechanism is going to be very useful in all your upcoming chapters. So CH3, actually this is R, sorry, this is R, and the CH3 came in and attached itself. Okay, and oh my, this, when the nucleophile comes in, it pushes away the pi bond. Okay, this is how it has joined itself, right? But what happens is this double bond O will form again because there is a leaving group which can break apart. The Cl minus actually is a bigger atom and it can break away very easily. Okay, so if the Cl atom want to comes out, okay, it can, and there is already one O minus and that can form double bond O. And this is MgCl. But the problem with ketone is, yeah, can you highlight the problem? Yeah, any idea? What could be the problem? Yeah, actually, Grignard is a strong reducing agent. Okay, Grignard is a strong reducing agent, and what happens here is when when you would have taken the Grignard, either you should write 1 mole. Okay, that's very important. And suppose if you would have taken, if you would have written not written 1 mole, or if you would have taken 2 moles. So Grignard being a strong reactive reagent, what it will do, the CH3 minus is going to come in and again attach here at this place. Okay, so R C, so one CH3 is going to come and add again, and you are going to get O minus MgCl. Okay, this is the second time addition. Is it clear?
Yes, sir.
And you can't stop it from happening. Why you can't stop it from happening?
So because we considered 2 moles.
No, if you would have not considered 2 mole, then also it can happen. There is a risk of excessive addition because Grignard is a strong nucleophile. It can come in and attack again on the one time it has added. Okay, it can add one more time. Okay, and when it can add one more time. Okay, and if you do the hydrolysis, and now this time you are not going to get back your double bond, because there is no Cl. One Cl was there that already left when we were doing the first time addition. Now this is not going to give you double bond O, R, C, OH, CS3 and CS3. Okay, when you do the hydrolysis. So you are going to end up with a tertiary alcohol. And this is called excessive addition. Is it clear? So you need to mention 1 mole. Okay, that is very, very important. Right?
Sir, we had to mention it so that excessive addition doesn't happen, right?
Yeah, but there is a risk of excessive addition. And if the excessive addition, because there is there is a question, many times question in integer type in JEE mains and in NEET also. How many moles of Grignard can be added to this? Yeah.
1 mole.
X, find the value of X. Yeah, Memuna. Would you like to add anything? One or two? Yeah, Vamsi. Or three? Tell me.
So you did not give the product, right?
No, just I am asking X. So what is the value of X? The maximum number of moles of Grignard which can be added to 1 mole of acid chloride.
Two, sir.
Yeah. How to?
Sir, at
You know,
last there will be no halogen left to continue the reaction further.
yeah. These are the famous question asked many time in all the examination, whether it is NEET or JEE. Okay, every examination. So first methyl came in and pushed away doubly bonded oxygen to and form O minus. That O minus and methyl joined itself. The O minus actually formed double bond again by pushing away the Cl. Cl was a good leaving group. That's why it came out. You ended up with a ketone. And now you added one more Grignard if it is given. Okay, because the question is asking how many Grignard reagent can you add. So you should consider one more Grignard, and if that is the case, then one more Grignard can add, come in and join. Now you will have O minus, but this O minus is not going to form again double bond. You have all carbon atom, they are not going to come out. Okay, so now you will put water and that will give you OH. That's it. So this is two, or there is one more I can give you, because these are the favorite questions which are given in many examinations. Okay, this is Cl. This happens with ester also. Okay, so tell me, 1 mole of this compound will add how many moles of Grignard? Yeah,
So 4.
4. Yeah, you need to be very careful. Memuna, would you like to add your answer? 2 moles for this, right?
Yes, sir.
Okay, why 2 moles? Because for one Cl will come out for another. Okay, this alkyl group is going to come in and join. And what about this one for aldehyde? Is it going to add 1 mole or 2 mole? Is there any leaving group? The CH3 minus is going to come in, it is going to form O minus. Is there some group which can come out and which can,
No, sir.
no, because H doesn't come out. Okay, so just one more. There it was possible 2 times, because the first time the Cl came out and then you ended up with a ketone, and that again was ready for the addition of second group. Okay, but not in this case. Aldehyde 1H is there, that is not going to come out. If you would have added 1 mole, that's it. Okay, so 3 moles, right? So now so you can prepare ketone from acid chloride or esters also. This is the same thing, but you need to write by using Grignard, because Grignard you need to know, because you are actually, you need to take, because you need to bring in the carbon. Okay, so that carbon will come in with the help of Grignard, but you need to be very careful to mention the 1 mole. Okay, if you would have taken, if you would not mentioned it, it can go wrong. Okay, if you want to stop at aldehyde, you need to mention 1 mole. So there is one more thing, one more reagent which everybody forgets. Okay, in so many years I know what are the reagents which everyone forgets, and this is the reagent which I'm going to tell you which everyone forgets. Okay, and which is better than Grignard. It is selective, and here in Grignard you do have to worry that it should not add 2 times, you should only add 1 time, you should add 1 mole. But for this reagent you can be relaxed, be very relaxed, because this is a reagent which is not going to add 2 times, just 1 time. And even if you would have taken 1 mole, 2 mole, or 10 moles, it will add only on RCOCl. So it is a very selective reagent, and this is CH3 whole twice CD. This is also an organometallic compound. It is known as dialkyl cadmium, right? Cadmium, it is less reactive, it is more selective. It's given in NCERT also, so it's very important. Okay, but everybody forgets it. It is because it is used only at this place and no other place. That's why everybody forgets it. Okay. So what is the reagent? This is known as dimethyl cadmium. You can write their name. And this is considered as a better reagent for the preparation of ketone from RCOCl. CH3 twice CD. It is less reactive, it is more selective. So it is going to add only on RCOCl to give you RCOCH3. That's it. Okay. Is it clear?
Yes, sir.
So this is a very important, but actually it is, everybody forgets it. And because it is given in NCERT, so this is so important that it can be asked in your JEE, mains, advanced, okay, on all the examination. Very, very important. Okay, be careful about this. And my past experience says of so many years that every year everybody forgets it. And I try to make them recall by asking them again and again in my classes. So be careful, right? So this is the preparation of ketone and aldehydes. Aldehydes, you need to do partial reduction. Ketones, you need to bring in an alkyl group with the help of Grignard, or you can bring in that alkyl group in a more better way in by using a more better reagent, and that is your dialkyl cadmium, dimethyl, diphenyl. Okay, you can have the specific name. I'm giving you the general name, that is dialkyl cadmium, right? So I hope this is clear. Now you can do the same thing for esters also. Esters are also same. CH3COOAT. Okay. You can, so how you are going to, from esters, how you are going to end up with CH3C LDI. So first of all, tell me this. Just one H. Yeah, which is the
Yeah.
reagent?
So H2
Yeah.
cadmium,
H2 and
cadmium CD.
no, that is cadmium is not the reducing agent. That is just for the organometallic. Instead of magnesium, alkyl magnesium halide, you take alkyl cadmium. So a hydrogen is reduction. Okay.
Yes, sir.
So, but how you are going to bring in that hydrogen? Just now in today's class only, I told you one reagent which was having just which was actually a cousin of LiLH, but it was better because it was having only one H. What was that reagent? Just try to recall it quickly.
So BSO4.
No, just one H. It was having only one hydrogen. I need only one hydrogen. Yeah, that was also used, but that was a
So
hydrogen H.
dival H.
Diagonal H, yeah. So just remember it wherever you are going to use, wherever in reduction, wherever in partial reductions you need one H, use diagonal H. So lot of questions are there in the recent years in JEE and NEET. Okay, so be very careful. This is diagonal H. Okay, so because it is having one H only, it will remove ethoxide and just H will you will get, right. Diagonal H is a very selective reducing agent for the reduction of ester.